News about graphing quadratics is there are two different types, two different forms of quadratics. One form is vertex form. That's the easier one. That's the one we're going to start with. And then there is standard form. Standard form, you have to do a little bit of extra work at the beginning, but then after that, it's the same process of doing the vertex form. Okay, so we're going to learn both forms today. You're going to practice both forms, and then, like I said, during fourth period, you guys will just do your dual enroll process. Okay, so when we go to graph parabolas, you have to know your vertex. Like, that is the very first thing we have to know. So it says no matter what form we see, the first point we want to plot is the vertex. Good news is we're starting with vertex form. And when we start with vertex form, that form actually gives you the vertex. So that's really nice because you don't have to find it. It is in the equation itself. The only thing you have to do, let me make this a little bit bigger for you guys. When you see this form, notice there's parentheses here, but in this one there's not. That's how you know it's vertex form. If you see a set of parentheses, you automatically know it's vertex form. Okay? Now, when you write your vertex, this number right here, the one that is paired with x in parentheses, that is your x coordinate. But notice how there's a minus sign there? That means you have to make it its opposite. So if this number in parentheses says -3, you're going to make it +3. Okay, so you might want to write that on your paper. Whatever number is in here, you are going to make it its opposite when you write it as the vertex. Now the number that's out here, the one that's after the parentheses, that is your y coordinate of your vertex, and since it has a plus sign, you're keeping it the same. So I always write opposite there, and then I always write same here. So if this said +3, that would stay +3. If it said -4, it would stay -4. Okay? Once you know your vertex, then the rest of the problem, like I said, we'll go through it. You guys will just plot 3 points and you'll end up mirroring them to the other side. That's why that axis of symmetry that I talked about yesterday is so important, because that's going to help split it in half. Okay, standard form will have to do something a little bit different just because standard form does not give you the vertex. You have to find it yourself. Okay? Are you ready? Yay. Okay. All right, so we're going to just talk about some different pieces of each function before we actually do the graphing. So the first thing we need to do is, looking at this function, we need to write our vertex. What would my vertex be? Yep. +4 and then 5. Yep. So this one became the opposite and this one stayed the same. Whichever one is paired with x, that's going to be your x coordinate. Whichever one's outside of the parentheses, that's your y coordinate. So 4, 5. Now I'm going to tell you right now that's really important, because if you write down -4 or 5, you're going to mess the whole thing up when you go to graph it. You're going to pick wrong numbers to plug in. It's going to be on the wrong side. So just be real careful that you remember to make that number its opposite. Yesterday we talked about how to know whether it was facing up or down. Who remembers? What do you think? The number out front. So this number out front, if it's positive, it is facing up. Up. It's okay. If it's positive, it is facing up like a positive person. They smile, right? Positive, it faces up. Negative would face down. Okay, your axis of symmetry. Anybody remember where that comes from? David, you think? The x equals 4. Yep. So your axis of symmetry is always an equation that starts with x equals, that number right there is the x coordinate of your vertex. Now, those of you that weren't here yesterday, you didn't hear me say all this. So that is the video I'll be sending you later on today. Okay, but you get to hear it again. Everybody else was here for that video yesterday. Or not that video, but for me teaching it. Domain is always the same answer. All real numbers, right? So you can write all real numbers. You can make the capital R with the 2 lines. You know that's not what I'm doing. I'm doing negative infinity to positive infinity. But I'm assuming most of you are probably going to use this. Most of you are not going to take the time to write out all real numbers. You're going to just use the symbol or that. But this is the one that we tend to use the most often. The range. Who remembers where the range comes from? It has to do with the y values. So we always start with the letter y. If it's facing up, what symbol do we use? Greater than or equal to, yep. If it were facing down, we would put less than or equal, yeah. And then what number goes here? The 5, because it comes from the vertex. The y-coordinate of your vertex is the number you put for the range. So yesterday we talked about how important that vertex is because the vertex gives you the x-coordinate is your axis of symmetry. The y-coordinate helps you with range, okay? Now, I don't think we talked about y-intercepts. Well, we did, but we had a picture to look at. We don't have a picture to look at. So the way to find the y-intercept, remember yesterday when you guys wrote your ordered pair, what number always went first? No, what specific number? We always put a 0 first, didn't we? So in order to find y, can't we just plug a 0 in right here for x and solve? So let's do that. We would put like y equals 3, and then in parentheses we would have 0 minus 4 squared plus 5. Now if you actually grabbed a calculator like I told you to, you guys can type this whole thing in at once. There is no reason to type that in as pieces. Just put the 3, put your parentheses, 0 minus 4, close it, then use the squared button, and then plus 5. Let the calculator do all the work. Uh, 16, 48, 53? Yeah. Okay. You should be getting 53. So see, a picture wouldn't have even helped because we wouldn't have had a graph that big anyway. So anytime you need to find the y-intercept without a picture, you just plug in 0 for x.
I wrote the answer down, but can you remind me again which button on the calculator is the square button?
X squared.
X squared?
So you see the caret, that upside down V, it's down the right hand side.
Yeah.
Right underneath it, I think, is the X squared button.
Okay.
Yeah.
I hit the caret button.
Well, you can hit the caret and then the 2.
Okay.
You can either do caret 2 or you can hit x squared. Any exponent other than a 2, you have to use the caret. The 2 just has its own button. Okay, so we're going to do the same thing for this one over here. Vertex. Hey guys, this is the most important part of this problem. -3, -7. So opposite, same. And then the direction, since the number out front is negative, down. And then our axis of symmetry comes from the x coordinate, so x equals -3. Domain, all real numbers, negative infinity to positive infinity. Range would be y is less than or equal because it's facing down, -7. And then for the y-intercept again, we're going to just plug in a 0 where the x is. So y equals -1/2, and then in parentheses 0 plus 3 squared minus 7. This one's going to be a decimal. So -11.5, right? Because it's a half, -11.5. Yeah. Let me see, because this, yeah, that's right. So -11.5. The calculator, it really depends on how you guys type in this. Any of you that have had me in like pre-algebra or algebra 1, I always have you use that ABC button when you're typing in a fraction. So in the calculator, it looked like this. Like that's how the answer was written. That means here's your whole number, here's your fraction. So -11.5. It's a mixed number, so I just turned it into -11.5. All right, so the y-intercept would be 0, -11.5. Now, I will, most of the time, I'm not going to ask you for y-intercept unless I give you the picture already. I would never have you plot a y-intercept that's going to be a decimal. I'm going to be more concerned about you guys telling me the vertex, axis of symmetry, domain, and range. Like those are going to be the biggest things that you guys have to be responsible for knowing. Okay? And then whenever you guys are ready, go ahead and turn the page. All right, so I think we have 2 that we're going to practice in vertex form, and then we switch to standard form. Okay, so let's focus on this first, and then we'll all do the graph together. Okay, so here's our first function. We are going to identify the vertex, and then we're going to put it on the graph. So what is my vertex? 2 and 1. So that one, the opposite of it, and then this one, the same. Remember, these are your notes that you get to keep. So anything I write up here, you might want to make that note so that way you don't forget. When you're sitting here working on your practice page, you're going to want to refer back to your notes, so that'll just help you out. Do we all remember how to plot points on a graph? The first number is the left or right, so we're going to start at the origin. You're going to go right 2 and then up 1. That should be your first point. I also will tell you that the graphs on your practice page, they're not near as light. You'll be able to see everything a lot better. This one just didn't print out very well. As soon as you plot that vertex, draw that dash line, draw your axis of symmetry in there for me, because we will use that when we go to mirror our points. All right, direction of the graph. If out front there's no symbol, it's positive, right? So it's going up. Domain, all real numbers. Yeah, we talked about it while you were gone. You don't have to do both. It's one or the other. I'd love for you guys to do this. They're just infinity symbols. It's not a big deal. Mine aren't that great either. And then the range, y, greater than or equal to the 1, the y value. Yeah, it didn't ask for axis of symmetry, which is kind of weird because this one down here does. So we're going to just write it over here, x equals 2. That's your axis of symmetry. Okay. Now, on this like T-chart, normally what you guys will see on your paper is you typically, if you had to do this T-chart yourself, you'd probably just have the X column and the Y column. You probably wouldn't have this center. This is where I'm going to show you what to type into the calculator, all right? But when you make your own, you don't have to do this. This is just for your notes. You should always have 3 X's, and the very top one is going to be our vertex, which we already know. So I'm not even going to show this work here because we know what it is. What was our vertex? 2, 1. Okay. Now, to get the next 2 ordered pairs that we want to plot, I don't think this is a hard concept, but some people forget how to do this every time I say it. If my axis of symmetry is at 2, and I told you guys yesterday, the domain is all real numbers, which means you're allowed to plug in any number you want to for x. So I could put anything here. I could put 10, I could put -30, it doesn't matter. I'm allowed to use any number. The problem is you have to be kind of smart about this. The further you get away from this pink line, the more likely it is that it's going to fall off the graph and you wouldn't be able to plot it. So the goal is to stay as close to that axis of symmetry as possible, meaning pick the 2 numbers that come right after 2, or pick the 2 numbers that come right before 2. So you're either choosing 0 and 1 or 3 and 4. Pick them. 3 and 4. Yeah, let's go to the right. Maybe on the other one we'll go to the left, but for this one, we're just going to go ahead and pick the 2 numbers that come right after 2. So 3, 4. Now, in the middle, I'm going to show you what to type into your calculator. And what you're typing into the calculator is just the original problem. So this, the x minus 2 squared plus 1, but you're replacing that x with a 3. So it'd be 3 minus 2 squared plus 1. And then this one would be 4 minus 2 squared plus 1. I need a calculator. I don't think I have one up here. All right, now these calculators are really nice because they store everything that you type in. So all you really have to do is type this one in, and then we won't have to type the whole thing out for the second one. So it's 3 minus 2 squared plus 1. Can you guys see that? Yeah. Okay, so then you hit equals. Did you all get 2? Okay, so then what you guys have to do is now, instead of typing the whole thing, hit that up arrow right there. Don't clear this. Hit the up arrow so that your cursor comes up. Scroll over so that it's over the 3 and just change it to a 4. And then hit equals again. And you get 5. Now, if you want to type the whole thing out all over again, by all means do it, but that's just going to be a waste of time when you can just use the stored memory. Okay, so now we're going to plot 3, 2, and then we're going to plot 4, 5. So I'm going to go over here. I'd go right 3 up 2, and then right 4 up 5. 1, 2, 3, 4, 5. And I know right now you guys are looking at that and saying, well, we only have one side of our parabola. But remember yesterday we talked about the points that match on each side. If I were to fold my paper right there on that dashed line, this one would have a mirror image over here. So if this point is 1 to the right of the axis, shouldn't there be 1 to the left? That would be its mirror image. If this point up here is 2 to the right from the pink line, start at the pink line and count 2 to the left. And now you have the whole thing. See, we used to make our students do a table of 5 points. But why do 5 when you can just do 3 and then mirror 2 of them? Right? Now this is supposed to be a U. So, you know, do your best. You might want to watch me first, unless you've done this before. But I always start above it and try to connect all your points at once. It is supposed to extend past those last 2 points because this would go on forever. So I just extend it and put arrows on the end. You guys okay with that? How many of you guys actually remember doing that last term with Adam, or you've done it before? You guys didn't graph them. I remember him coming to me and telling me that he was only getting through like what we did yesterday. But that's okay. I told him it was fine because I was going to teach it to you anyway. Are we good? Because we're going to do one more in vertex form. So we're going to do this one down here. Pretty much the same process all over again. We're just going to have different numbers here. So our vertex is what? Yep, so this number here, make the opposite, so it's -2. And then this one here, keep it the same, so it's -1. Axis of symmetry? X equals -2. Yeah, you guys... I know it seems like that's me being picky, but it's not, because axis of symmetry, it's a vertical line. Vertical lines start with x equals. Like, that's why I make you write an equation. I forgot to plot this point too. So -2, -1. Will it be facing up or down? It's going to face down because there's a negative sign out front. Domain? Yay. Thank you. And then for range this time, it is y less than or equal to -1. Good job. Okay, so you guys can go ahead and in this table down here, go ahead and just... let's put our vertex, which was -2, -1, in that top row. You don't have to write out all the work for the vertex because we already know what it is. And then for -2, I will tell you this. When you guys type things into the calculator and you just use the memory, if you type in the first number as a positive, it's much easier if the second number is positive. If you type in a negative the first time, it's easy to keep it. It's easier to replace it with another negative. So if I went to the right, it would be -1, but then I'd have to replace that with a 0, and it wouldn't replace as easily. So I want both of mine to be negative. So I'm going to use -3 and -4. You could do the other one, I promise. Like, it doesn't matter which way you go. You're going to get it to mirror the other 2 points anyway. So I'm going to use -3 and -4. And what I'll tell you is the -3 will mirror what the -1 would have given us. And the -4 would match what the 0 would have given us. So that's why I said it doesn't matter. Like this half of the room, could go to the left, and that half could go to the right, and we'd all get the same two answers over here anyway, okay? So when you type this into the calculator, we have to use this whole thing, including that negative sign out front. So it would be a negative sign, parentheses, then we're plugging this number in, so negative 3 plus 2 squared minus 1. Your negative button, these two will not match your minus sign. Like, they will look different in the calculator. Let me just show you. Because when you type this in, the negative button's down here at the bottom, this one, the minus sign is over here, and they even look different on the screen. So if you type in a negative, parentheses, negative 3 plus 2 squared, then the minus, look at the minus sign in comparison to my negative signs. You see the difference? Might be easier to see it on your calculator, I don't know, but this minus sign is always lower and it's like longer in length. The negative signs are up a little bit higher and they're shorter in length. So that's just a way to check and make sure that you guys have it typed in right. Just make sure you get a negative 2 to pop up on your calculator. That's what matters, because I can't type these in for you while you're doing your practice or while you're taking your test. So you need to be practicing while we're going through this on your notes. Negative 2. And then just scroll over to that 3 and replace it with a 4. So see, I got to leave the negative sign in there. I just had to replace the 3 with a 4. And then hit equals again. You should get negative 5. So you are plotting negative 3, comma, negative 2, and then negative 4, comma, negative 5. Those are your ordered pairs. So negative 3, negative 2, and negative 4, negative 5. So this point is 1 to the left of my axis of symmetry. So you want to start at your axis and go 1 to the right. And then you'll do the same thing down here. This one was 2 to the left, so I'm going to go 2 to the right. And then just, I have a harder time with the ones facing down. I usually can't do it all at once. But if you do it like this, you still need to make sure that up there at that vertex, it still looks rounded, that it looks like a U and not a V. Do you guys think there could ever be a time where like this vertex is so low down here that you might only be able to plot 1 point on each side of it? Yeah, it will happen. Like, it might even happen on your practice page. Like, your vertex may be so low and it facing down that only one of these that you put in the chart can be plotted and it can be mirrored, but the other one might just fall off the graph. Who cares? If one of them doesn't fit, you just don't plot it. No matter what, you'd always get the vertex and like these two to fit. Just, whoo, whoo. It's okay. I don't think I have tissues. I don't think I have any paper towels. You're fine. I'm more worried about your stuff. It'll wipe up off the table. The same thing could happen if your vertex was way up here towards the top and it was facing up. You might just get like 1 point to fit and mirror it, and then the other point might fall off. Okay, that's the end of the vertex form. What's the matter, Kim?
You just lost me.
With what? Which part? Which part? What did I move on to? The negative 3, negative 2?
Let me look at yours.
Yeah, so then I plotted those three, and then I mirrored this one. So I said, okay, this one is 1 to the left, so I went started at the axis and go 1 to the right. And then this one was 2 to the left. So go to, sorry. Stop me, I go too fast. All right, so when you guys get your practice page, there are going to be, I think, 4 that are in vertex form. And refer back to these, okay, because these are your 2 examples of vertex form. And then when we switch to standard form, this whole like making the chart like we've been doing here, that's the same. They're still going to ask you domain and range. That's the same. The only difference is that it does not give you the vertex. You have to find it. So the very first thing we're going to do with standard form is I'm going to teach you how to find the vertex. Okay? But that's the only difference. Once we get the vertex found, everything after that is exactly the same that we've been doing. All right? So standard form's on the next page. You just have to flip it over. Yep. Yeah, this third period doesn't end until 2 o'clock. Technically 2:05. I usually just let you guys take your break at 2. This reference sheet right here, if you look, there is a box, top left side. It actually says on here axis of symmetry, also the x-coordinate of the vertex. It gives you this tiny little formula, which you're about to see right here. It even says it's on the reference sheet. We're going to use it so much, you guys will memorize it because it's part of your quadratic formula too. So it's something that you will hear often, but it is on this. So anytime you need to refer to your axis of symmetry formula, it's on here. Okay? All right, so when we give you standard form, notice there are no parentheses. This is the process of finding your vertex right here. Very first thing we're going to do is we're going to find the x-coordinate using this formula. So it looks like this, negative b divided by 2a. What that means is this negative sign really means opposite. So the opposite of b. Okay, so see this middle term? Our middle term is the b value. If that said plus 4, I'd be putting a minus 4 up here, negative 4. If this said minus 3x, I would put positive 3. It's just the opposite of whatever that number is. And then on the bottom, you're going to divide by 2 times whatever number is out front. Okay? Once we have our x-coordinate, how do we always find y? What do we do with the x? What did you just say? No, what do we do with the x? Like if x is 4, what do I do with that 4 to find y? You guys literally just did it multiple times back here. When you knew x, how did you find y? We plugged it in. There you go. So you just do a plug and chug, right? Okay, so once we know our x, we're going to find the y by plugging it into the original equation. And then we will have our vertex. All right, so go down to the bottom. We're going to walk through this process. Standard form, you have A is 1, B is negative 8, C is 14. So it says find the x in the vertex. So we're going to use this formula, the negative b over 2a. So if b right now is negative 8, what number do I put up top? Positive 8. It's always its opposite. On the bottom, it's always a 2, and then you're going to multiply it by a, which was 1. What's 2 times 1? 2 times 1 is what? 2. And 8 divided by 2? 4. So x equals 4. We just found our x coordinate. You always have to multiply out the bottom before you do your division. That's why I asked you guys what 2 times 1 was and just made it a 2, and then you divide. Axis of symmetry, isn't that what we just found? X equals 4. Okay, so there it is, x equals 4. Is the number out front positive or negative? Positive, so it is facing up. Domain, all real numbers, so negative infinity to positive infinity. Now, in order to find the range, don't I need to know what the y value is of the vertex? Okay, so normally in this chart down here, the top row is the row that we use for the vertex. So if my x of the vertex was a 4, we can't just write we can't write vertex here. We actually have to do the work to figure out the y. So when you do this equation, there are 2 places where the letter x is. We are going to have to put the 4 there and the 4 here. When you plug it in, you're plugging it in for x. So I would have 4 in parentheses squared minus 8 times 4 plus 14. That right there is the original equation, but where my x's were, I've just replaced them with 4's. Okay? And anytime you square a number, anytime you square something, that something needs to be in parentheses. Okay, so if you're squaring a 4, put the 4 in parentheses. If it's a negative 3, put the negative 3 in parentheses before you square it. Getting negative 2? 1630, yep, it'd be negative 2. Just make sure you guys are typing that in and getting negative 2. Because if you get something different, you've typed it in wrong. So that top row is our vertex. So now we know everything we need to know. Because we know our vertex, we can plot 4, negative 2. Did everybody get negative 2? Okay. Well, then I plotted it over here. So there I went right 4 down 2. And then I'm going to draw in my axis of symmetry like we typically do, that dashed line. I'll finish the chart in a minute. The range, we said we needed the y value. Now that we know it, we can do y. It's facing up, so the symbol is greater than or equal to negative 2. Now the y-intercept is super easy in standard form because look right here. If you guys had to find the y-intercept, meaning you plug in a 0 where x is, if you plug in a 0 here and here, wouldn't those two terms just disappear? And isn't it just going to leave c? So we just know the answer is 14. So actually it's easier to do a y-intercept when it's in standard form. Because if you plug in 0 squared, that's 0. 8 times 0 is 0. So those are zeros. And then it's just plus 14. So the y-intercept would be 0, 14. I'm just going to put on here that it's the c value, the constant. All right, what two numbers either come right before 4 or right after 4? 5, 6 or 2, 3. It doesn't matter. I'm going to go to the right this time. I'm going to use 5 and 6. But if some of you have already done it, because I feel like some of you are working ahead of me, if you've already done 3 and 2, that's fine. Just make sure that your 3 matches my 5 and that your 2 matches my 6. That's all you have to check. You don't have to erase what you did. So I'd replace both of my 4s with 5s. And then I would replace both of my 5s with 6s. So again, as long as you had typed this into your calculator, that vertex, then you're just using your memory again. Scroll over to the first 4, change it to a 5. Scroll over to the second 4 and change it to a 5. And then hit equals. Is that right? Yeah. Okay. You should get a -1 and a +2. Whenever you guys have your T-chart filled in, then you're going to plot 5, -1, and you're going to plot 6, 2. Let's see, +5, -1, +6, +2. So right now, all I have is the right side of my parabola. Had anyone done 3 and 2 here? Had anyone worked ahead of me? No? Okay. Well, never mind. If you look at this point right here, the 5, -1, it is 1 to the right of my axis. So if you start at your axis and you go to the left one, it matched. That would be its mirror image. This one up here is 2 to the right. So I'm going to start at my axis and count backwards 2 to the left. Then you've got your 5 points that you need. So again, like I said, the only difference with standard form in comparison to what we did with vertex form was just right there at the beginning where we had to find the axis of symmetry, which gave us our x coordinate, and then we had to do a plug and chug to find our y coordinate of our vertex. Everything beyond that is exactly what you do on vertex form. How many are on the back page? Is there just 1 or 2? Okay. Flip it over when you're ready. I'm going to do one more, and I know that that's going to put me past 2, but if it goes to 2:05, I'm still going to give you a 10-minute break anyway, so you'll be fine. All right, this one right here, The only reason this one's a little bit more complicated is that negative sign. That negative sign, you have to remember, is technically out front of your set of parentheses when you go to plug a number in there. So just keep that in mind. Because we are going to go ahead, I'm going to go ahead and do the entire vertex first. I don't like how they're kind of jumping around. I want to do the X, which is our axis of symmetry. We'll do a plug and chug to find our Y, so that way we have the vertex right off the bat. Okay, so to find the X, what's the opposite of the B? What's opposite of that? It'd be -2. And then on the bottom, it always starts with +2, and you're multiplying it by A. Well, what number is out front? If it's just a negative sign, it's -1. And then what is 2 times -1? It'd be a -2 on the bottom. And -2 divided by -2. +1. So there's your X. So I went ahead and stuck a 1 right here because I'm going to do my vertex here in just a second. The only other thing I'm going to do is I'm going to write the axis of symmetry because it was x equals 1. That's what we just found. Okay, so for the vertex, this is my original function. It was -x squared, so the x goes inside the parentheses. Then it was +2x, so again, I replaced the x with a 1, and then there was a +2 at the end. It's right up here, you guys. That is the original. So all I did was I rewrote it. I just plugged in a number. So type that into your calculator, and that'll give you your y coordinate of your vertex. You should get 3. Right?
Yeah.
I've been doing math a long time. I love math. Which way will this graph face? Down because it's negative out front. Your domain is always the same answer. So all reals or -infinity to +infinity. The range this time would be y is what? Less than or equal. And then we already know the y value because we just found it. 3. Y is less than or equal to 3. And then your y-intercept is just that constant in the original function. What's the number at the very end? 2. So it's 0, 2. So I'm going to plot 1, 3, and I'm going to draw in my dashed line. So 1, 3, and then draw in your axis of symmetry. What are my two numbers that come right after 1? 2 and 3. So if you had already typed this in, the one right above it, the ones, you're just doing the same thing, but you're now replacing the ones with 2s, and then you'll replace the 2s with 3s. I need you guys doing that. Three, 2, and -1. I'm sorry, the 3 was already there. 2 and -1. If you guys got that typed in and replaced. Then we'll plot 2, 2, and 3, -1. Now I know sometimes I told you guys you can either go to the right or to the left, so I chose 2 and 3 because if I didn't choose 2 and 3, I would have had to do 0 and -1. And I told you before, if you already have a positive number typed into the calculator, you don't want to replace it with a negative. It messes the whole thing up. So that's why I just kept to the right. So this was 2, 2, and 3, -1. So my 2, 2, this point, 1 to the right, so I started at my axis and I went 1 to the left to mirror it. This point down here was 2 to the right, so I started at my axis and I counted 2 to the left. Then you have all 5 of your points that you need to make your parabola. When you guys have that one done, then you can take your break. But you need to be back in here in 10 minutes. 2:14.